Imagine not knowing where you are or what you're doing every 3 seconds. Strange, isn't it? While this may not happen to us that frequently, we do spend about a third of our lives in a state of unconsciousness, what we call sleep. For instance, someone who lives to the age of 90 will have spent around 30 to 35 years sleeping. Let that sink in. Are we wasting an enormous chunk of our lives by staying unconscious, or is there something deeper going on? Now, suppose we've figured out how many hours we should sleep each day. Here's a more interesting question. How many times a day should we sleep? Should we adopt polyphasic sleep cycles like some of history's greatest thinkers? Let's explore the fascinating world of sleep together. First, let's understand an important fact. Among animals with nervous systems complex enough to exhibit sleep, we haven't found a single species that doesn't sleep in some form. Take sponges, for example. They don't have a nervous system, so asking whether they sleep doesn't make much sense. This shows that sleep is closely tied to the nervous system. For animals with centralized nervous systems, especially those with brains, sleep takes on different forms. Some, like us, sleep in clearly defined cycles. Tiny nematodes experience brief inactivity throughout the day. Whales can shut down one hemisphere of their brain while keeping the other active. Sharks, on the other hand, have been observed swimming against currents to stay in place while taking short naps. Even reptiles, once thought to have unclear sleep patterns, have been found to enter sleep-like states. Birds, which we've all seen dozing off, are even more remarkable. Some species, like the alpine swift, can sleep while flying during migrations lasting up to 200 days. Clearly, the forms sleep takes are as diverse as the animal kingdom itself. Now let's talk about sleep duration. Humans, believe it or not, aren't the longest sleepers. Brown bats take the crown with 20 hours of sleep per day, followed by pythons at 18 hours and tigers at 16. In contrast, humans with an average of 8 hours are relatively short sleepers. Of course, this changes with age. Newborns sleep up to 16 hours a day, while older adults might get as little as 5.5 hours. Giraffes, surprisingly, need only 2 hours of sleep, while horses and donkeys manage with just 3. Sleep duration is as varied as sleep styles across species. Here's the fascinating part. Sleep seems to be a fundamental trait of being an animal. In fact, some species sleep for so long that it raises a thought-provoking perspective. What if sleep is the natural default state, and waking up is the exception? It's a wild idea, but who knows? And we haven't even touched on dreams yet. Sleep is full of mysteries, waiting to be unraveled. So let's dive deeper and see what makes it such a vital part of life. I won't dive into the biology of dreams here. That's a topic for another video. If you don't want to miss it, make sure to turn on channel notifications. But when you pair the mysteries of sleep with the surreal nature of dreams, it's no wonder humanity has developed an entire mythology around sleep. Despite all its strangeness, our research so far shows that sleep is just another vital biological process, no different than the liver breaking down toxins or the kidneys filtering blood. Think of it as the brain's pit stop, a chance to clear out waste, repair itself, and reset, just like how a Formula One car needs periodic pit stops to maintain peak performance. Without this crucial downtime, things would quickly fall apart. Let's clear up a common misconception. Sleep is not simply a state of inactivity. In fact, during sleep, many biological processes kick into overdrive. Tissue repair, protein synthesis, muscle growth, and hormone release are all significantly accelerated while we sleep. That's why athletes and bodybuilders emphasize the importance of rest. Muscles don't grow during workouts, they grow while you're resting. The brain, too, works tirelessly while we sleep. It consolidates memories, clears out toxic waste, strengthens neural connections, and prunes away unnecessary ones. This behind-the-scenes work sharpens your learning, problem-solving skills, creativity, focus, decision-making, and memory. But when you don't get enough sleep, all these cognitive functions take a hit. Studies show that people sleeping fewer than 4 hours a night suffer dramatic declines in mental performance. Even simple tasks become overwhelming. Sleep-deprived individuals often experience microsleeps, brief moments of unconsciousness without even realizing it. And it doesn't stop there. Research shows that people who regularly sleep fewer than 6 hours a night may not feel the effects immediately, but over time, their performance declines to the level of someone who hasn't slept for 48 hours. What's worse is that your brain can start to adapt to this sleep-deprived state, locking you into a cycle of subpar mental function. Returning to your full cognitive potential can take weeks or even months of consistent, healthy sleep habits. And some research suggests that chronic sleep deprivation may cause lasting brain damage. During sleep, key brain regions like the amygdala, hippocampus, and prefrontal cortex become more active than during waking hours. This helps regulate emotions, improve mental health, and support recovery from conditions like depression. Sleep also plays a role in physical health, reducing risks of obesity, metabolic syndrome, and type 2 diabetes by regulating hormones. Conversely, insufficient sleep increases the risk of high blood pressure, heart disease, and even premature death. Your immune system benefits too. Cytokines, which fight inflammation and infection, are released in higher quantities while you sleep. So sleep is not just downtime, it's an essential biological reset, as important as eating or breathing. But how much sleep do we really need? Let's debunk one of the biggest myths out there. The idea that geniuses sleep less and fools need 8 hours. That couldn't be further from the truth. According to science, the optimal amount of sleep depends on your age. For adults, the sweet spot is 7 to 9 hours, with the average being about 8 hours. Anything less than that starts to take a toll. Studies show that sleeping fewer than 7 hours a night increases your risk of early death by over 20%. So no, cutting back on sleep doesn't make you smarter or more productive. It just leaves you exhausted, cognitively impaired, and at higher risk for serious health problems. If you want to be more successful, make sure to get enough sleep, but don't overdo it. For example, sleeping too much can also be problematic. Research shows that sleeping beyond the recommended amount leads to cognitive function decline, increased risk of cardiovascular diseases, obesity, and even a 30% higher risk of death. So the upper limits of sleep are important as well. But there's still one question left open. What happens to us while we sleep? It might sound a bit eerie, but if you've ever observed someone sleeping with their consent, and for scientific purposes, you might have noticed that during certain stages of sleep, even though their eyes are closed, their eyeballs move rapidly back and forth, or up and down. This is called rapid eye movement, REM. And the stage where this happens is called the REM stage. The stage where this movement doesn't occur is called the NREM stage, which stands for non-rapid eye movement. Let me show you directly what typical behaviors during sleep look like. Here's a graph showing how deep you are in each sleep stage before falling asleep, while you are asleep, and after waking up. On average, an adult falls asleep in about 14 minutes and usually enters the first NREM stage. During this time, your eyes move very lightly and slowly, and it's very easy to wake up. This is why, in noisy and bright environments, it's hard to enter deeper stages of sleep. For example, if I woke you up during this stage, you could argue that you haven't really fallen asleep yet, even if your brainwaves show otherwise. There's a reflex inherited from our tree-dwelling ancestors called the hypnic jerk. It happens most often in this stage, when you suddenly feel like you're falling and wake up. This evolutionary adaptation prevented our ancestors from falling from trees while asleep. And today, we experience it as a diminished reflex. Then comes the second NREM stage, where eye movements stop completely, and you may start dreaming. In this stage, it's still easy to wake up. After leaving this stage, we enter the deep sleep stages, also known as slow-wave sleep, third and fourth stages. Many of the dreams we experience during REM actually begin at this point. But even here, the frequency of dreams isn't as high as during REM, and it's much harder to recall dreams from this stage. A significant difference between REM and NREM becomes apparent if you have a condition like sleepwalking. You tend to do this during the NREM stages because, unlike REM, your muscles are not paralyzed and can move. For example, people with restless leg syndrome unconsciously tighten and relax their legs during this stage. These movements may become more exaggerated in those who tend to move excessively. Observing these behaviors from the outside can be quite eerie, but they are physiological issues that don't require treatment. Later, you go through transitional stages and then enter REM sleep for the first time, usually about 90 minutes after falling asleep. During REM, you begin to dream, and neurotransmitters like GABA and glycine help create a temporary paralysis in the body. However, here's the interesting part. Even though REM is technically the deepest sleep stage, the brain activity during this phase is very similar to when you're awake, which is why this stage is sometimes called paradoxical sleep. During REM, intense brain activity can trigger visual and auditory experiences, creating what we call dreams. Many anomalies related to dreams occur during this phase. For example, in lucid dreaming, where you realize you're dreaming and can sometimes control the dream, certain brain regions associated with higher cognitive functions become unusually active. Studies suggest that this ability can be developed, and certain medications used in Alzheimer's treatment have been shown to increase the frequency of lucid dreaming by enhancing the accumulation of a neurotransmitter called acetylcholine in the brain. Sleep paralysis, a phenomenon where you wake up but remain temporarily paralyzed because your body hasn't exited REM paralysis yet. This often triggers feelings of fear, which can be exacerbated by lingering dream imagery, leading to a terrifying experience. People may hallucinate voices, screams, or even full sentences during this state. Sleep paralysis can also occur when falling asleep, hypnagogic paralysis, and is commonly experienced by individuals with sleep disorders. Around 8 to 50% of people experience this at least once in their lifetime, and 5% may experience it regularly. So if you experience it at least once in your life, don't be surprised. I know it's a scary experience, but that's how the brain works. These aren't as mystical as they might seem, but they are fascinating neurological phenomena. When combined with human imagination, they can lead to bizarre experiences like encounters with ghosts, fairies, or alien abductions. Now let's get to our last and main question. How many hours of sleep do we really need each day? Once, twice, or 5 times? Here, we come across the topic of monophasic sleep, which is taking the daily sleep requirement in one go, and polyphasic sleep, which is taking the daily sleep in multiple sessions. For example, instead of sleeping 8 hours at once, is it okay to sleep 2 4-hour naps or 8 1-hour naps? Let me make it clear. All primates, including humans, are monophasic sleepers, meaning they get their daily sleep needs in one go. On the other hand, polyphasic sleep, which means sleeping 2 or more times a day, is the standard sleep strategy of mammal ancestors and animals that have evolved earlier. There has been a transition between these two, and we can still see species that sleep twice a day. In fact, humans might also be one of these species, which I'll get to later. Our wild ancestors probably slept monophasically because there was little reason to be active at night and a lot of risks. However, this may have changed in the thousands of years following the agricultural revolution. According to some research, some texts from before the 18th century indicate that it was quite common to wake up in the middle of the night for 1 to 3 hours. People would do things like pray or reflect on the dreams they had during this period of wakefulness in the cool of the night. The first sleep phase was called prima somno, first sleep, in Latin, and the second sleep or morning sleep was called secunda somno. How common this was, or who it was common among, we don't know for sure. However, with the Industrial Revolution, as work hours became more regulated and we began to control electricity and light, monophasic sleep became widespread, and we adapted to it. In fact, psychiatrist Thomas Weir demonstrated that when human subjects were deprived of artificial light at night, their sleep patterns naturally became biphasic, with a period of wakefulness of about 1 to 2 hours between 2 sleep phases. This means that if there were no issues with going to school or work in the morning, experiencing a brief interruption in sleep during the night doesn't necessarily indicate a sleep problem, especially if you're still getting enough total sleep. So what about these brilliant minds like Davinci, Tesla, and Napoleon? Didn't they create masterpieces and revolutionize things because of polyphasic sleep? Well, there's almost no evidence showing that these people actually followed polyphasic sleep. Most of this has been exaggerated by their fans or spread by those chasing after myths. It's true that some highly productive people sleep less or may have practiced polyphasic sleep, but this doesn't mean they were operating at a cognitive level lower than their normal sleep would allow. Within the framework of evolutionary diversity, some people can be quite productive with 5 to 6 hours of sleep. However, there's no academic study showing that extreme reductions in sleep, like 1 to 2 hours per day, lead to high performance. Even if some of these brilliant minds slept less or followed polyphasic patterns, it doesn't mean that by doing the same, you can reach the same level of brilliance. Perhaps due to their genius or motivation, they may have challenged sleep or their health, but their brilliance wasn't because they slept less. This is something I can state clearly. In summary, polyphasic sleep is not a functional method for most people, except for those with a lot of free time and nerves of steel, because it's very difficult to apply. It might sound cool, and short naps of 20 minutes or an hour can help you push through at times. But we know that humans' large brains didn't evolve with such a sleep pattern. Claims about polyphasic sleep improving efficiency or creativity don't have scientific backing. Maybe you can achieve short-term advantages, but in the long run, disrupting daily hormonal cycles and circadian rhythm will cause more harm than good. So as you can see, sleep isn't rocket science. The recommended sleep pattern for adults is 1 or at most 2 sessions during the night, totaling around 8 hours. But this simple conclusion opens the door for new learnings about sleep, which will be covered in future videos. Until then, take care of yourself and don't neglect your sleep. See you in the next video. Goodbye.